Hello, my name is Laura Clark, and I'm a student at Stanford University, and I'm very grateful to get to be an ARC scholar. My research is motivated by the problem of plastic in the ocean. As you've probably heard, a lot of plastic enters our ocean every year. And once in the ocean, this plastic breaks down into smaller and smaller pieces, and these small pieces are known as microplastics. Microplastics are defined as being less than 5 millimeters in size. This is a picture of some microplastics that have washed up onto a beach. And one thing you can notice from this picture is that they come in many different shapes. They can also be many different densities. Because microplastics are such a problem in the ocean, we'd like to understand how are they transported by ocean flows, where do they go, and how do they get there? And these characteristics, their size, their density, and their shape, are important to determining how they're transported by ocean flows. In my most recent experiment, we measured the dispersion of microplastics. Dispersion means that if microplastics are all released at the same location, how much do they spread out after they've traveled away from that spot? And it's important to understand dispersion because, for example, if you have a lot of microplastics in a river that are being released into the ocean, then you want to know how much do they spread out after they've entered the ocean. And dispersion helps us understand more broadly where are microplastics going and how are they getting there. Dispersion is frequently used as a model parameter for modeling microplastics in the ocean. But because it's not well understood, it's often assumed to be the same for all microplastics in all kinds of ocean flows. But we would expect that their shape and their size, et cetera, is very important to determining how they disperse. This is a video of my experiment. We release microplastics close to the surface of a wavy flow, and then they travel downward and downstream to land in a catch grid at the bottom. And because they land in a lot of different locations, but they were all released at the same location, their landing locations tell us how much the microplastics spread or dispersed while they were in the flow. Here is a plot of some of the main results from our experiment. So we're plotting the ratio between the dispersion of the microplastics in the presence of waves against the dispersion when there were no waves. And we can see that the microplastics disperse much more when there were waves than when they're not waves, up to 400% as much. I'm plotting these against the particle shape. So rods are on the right-hand side and disks are on the left-hand side. And we can see that particle shape is also extremely important. Rods disperse more than disks, and thinner rods disperse more than thicker rods. And so knowing things like this about the impact of waves and microplastic shape on the dispersion of microplastics gives us a sense of how microplastics are being dispersed in the ocean and helps us then better understand where microplastics going and how are they getting there in the ocean. Thank you for listening.